All right, so this is the final exam review for chapter 4. So the first thing we want to start off with is the rules for negative exponents. If you remember, when we have a base a to a negative exponent such as n, what we do is move the base a to the n to the opposite side of the fraction bar, and then the exponent there becomes positive, right? So it's reciprocal of a to the n, right? It's make it into a reciprocal. So here we go. So we have 6 to the negative fifth. So we can simplify that, and what we're trying to do is write each one of these. And remember, we write them always using positive exponents. Remember, we always write them using positive exponents. So 6 to the negative fifth would be 1 over 6 to the fifth. And b, which is 2x to the negative fourth, would be 1 over 2x to the fourth. And c, it's the same deal, only we have a coefficient negative 7. That remains the same, but we move the p to the negative fourth to the opposite side of the fraction bar. So our result is negative 7 over p to the fourth. So that means that 4 to the negative 1 would be 1/4. And 2 to the negative 1 would be 1/2, which is what we have here. So 4 to the negative 1 is 1/4. 2 to the negative 1 is 1/2. We subtract these and we end up with negative 1/4. But what we really want to take away from all of this is that when you have a negative exponent, what you do is move it to the opposite side of the fraction bar and then change the exponent to a positive, which is what we did in each one of these cases. Then there are the power rules for exponents. So if we had a and b real numbers and then we have m and n integers, then a to the m to the nth is a to the mn. What we do here, what we have here is a power rule over a power. So raising a power to a power. So when you raise a power to a power, as it says here, multiply the exponents. Then we have a power over a product here. We got a product between a and b. Notice that when we have that case, we apply the exponent to each one of the factors in the product. So as it says here, to raise a product to a power, raise each factor to that power. Then in C, we have a power over a quotient. And as you can see here, we've applied the power to both the numerator and the denominator. As it says here in C, to raise a quotient to a power, raise the numerator and the denominator to that power. So in A, we have a power to a power. So remember, when we have a power to a power, we multiply. So we multiply 5 times 4. And we get r to the 20th. Then in B, what we have here is a product to a power, because negative 3 times y to the 5th is a product. So remember, when we have a product to a power, we apply the exponent to both of the factors in the product. So we apply the square to the negative 3, then we apply the square to the y to the 5th. So we square that negative 3. We'll do that in the next step, but notice right here what we have here is now we have a power to a power, so we multiply 5 times 2. We square the negative 3, and then we multiply the 5 times 2. So that simplifies into 9y to the 10th. And in C, we have a quotient to a power. So remember, the way we handle that is we apply the power to both the numerator and the denominator. So we're going to have 3 to the third over 4 to the third. So 3 to the third is 27. 4 to the third is 64. So this simplifies to 27/64. Now in D, we're going to have a lot of things going on as we work through this. But the first thing we've got to do, what we have is a quotient to a power. So the first thing we're going to do is apply the 3, the cube, the exponent here, to both the numerator and the denominator. So in the denominator, we're using a power to a power. That's why they're multiplying the 2 times the 3. Then here, now we have negative 3 into the fourth. Now we have a product to a power. So we've got to apply that 3 to the cube to both the negative 3 and to the into the fourth to the third. Multiply, because basically what we have here is a power to a power. So we cube that 3. We end up with negative 27. Multiply the 4 times the 3. We get into the 12th. And then we end up with negative 27 into the 12th over m to the 6th. All right, so this next bit has to do with combining like terms. So we probably are familiar with this. But for example, in this first piece, we got 7x, x, and negative 2x. These are all like terms. The reason why they're like terms because terms containing exactly the same variables raised to the same powers may be combined. Which brings us to this next example here. We've got 1/3 x squared, negative 2x y squared, 1/3 x y squared, negative 2xy squared, 6xy squared, xy squared divided by 2. Notice that we have the same variables here raised to the same powers. So for that reason, these are also like terms. So here we are. We're going to combine like terms here. So if we look at this first one here, notice that we've got z to the fourth and we got x to the fourth terms, right? So we can combine the x to the fourth and we can combine the z to the fourth, which is what we do here. We've just combined our like terms because the same variables raised to the same powers can be combined. Now looking at B, we've got some t terms and we got some r terms. So we can put the t terms together and we can put the r terms together. So 3t minus 4t is negative t. 4r minus 8r is negative 4r. Now C gets a little more complicated. We got 2 sets of variables in each term. But notice we got x squared to the z, and then we got x squared to the z here. Those two can be combined. So 5x squared z plus 8x squared z gets us 13x squared z. And then these other x cubed z squared, these can be combined. So negative x cubed z squared, negative 3x cubed z squared plus 12x cubed z squared gets us to 9x cubed z squared. We're just combining like terms there. So let's look at this one here. It asks us to combine like terms. So the first thing we got to do is deal with these negatives, right? So notice that the first thing we do is distribute the negative signs. Notice that I not only distribute the negative sign to the first term, but also the second term. This becomes negative 4q, and this becomes negative 1. negative 5q minus 8. Now I've got to combine my like terms. One way to do this would be to group all the q's together and then group all the constants together. So notice here 6q minus 4q minus 5q. We're identifying our like terms here, 7 minus 8 minus 7 minus 1 minus 8. 6 minus 4q, 6q minus 4q minus 5q gets us negative 3q. 7 minus 1 minus 8 gets us negative 2. What we've done is combine our like terms. We can simplify this to make this look a little neater. So we end up with negative 3q minus 2. Now this problem is not that hard. Just take your time. First, make sure you distribute the negatives, and then make sure that you collect your like terms properly so that you end up with the right answer. Now we're going to talk about FOIL. Remember, FOIL is first, outer, inner, last. So if we were to FOIL these two binomials, the first thing we do is multiply the first terms, which are 5r and 2r. So 5r times 2r is 10r squared. Remember to square the variable. This is r times r is r squared. This is, remember, the same thing as the product rule. This is r to the first. This is r to the first. What we do is add our exponents. Or just so again, remember to square your variable when you FOIL. Then we'll deal with the outer terms, which are 5r times minus 5. So 5r times minus 5 is negative 25r. Then we'll handle the inner terms, which is negative 3 and 2r. So negative 3 times 2r is negative 6r. And then the last is negative 3 and negative 5. So negative 3 times negative 5 is positive 15. So what I have here is this polynomial now, but there's still one more thing for me to do. Notice that negative 25r and negative 6r are like terms, so I can combine those two together to end up with the quadratic that we've created by foiling two binomials. Let's take one other look at FOIL here. Here we have a situation like this. So if you like to draw the arrows, 4k times 4k is 16k squared. Remember to square your variable. Always, when you get a variable times a variable, it's going to be squared. The next thing we would do is 4k times negative 9, so that gets us negative 36k. That's our outer. Then we'll do our inner, negative 6 times 4k, which is negative 24k. And then we do the last. Negative 6 times negative 9 is positive 54. And remember, there's one more thing we've got to do here. We've got to combine our like terms here. Negative 36, negative 24 ends up with negative 60k. So we end up with our quadratic that we created by multiplying two binomials, which is the FOIL method.